Imagine waking up one morning to find out that everything humanity has ever known, our sun, our planets, everything we call home, could be swept away, not by the slow death of our sun, but by a silent cosmic thief passing in the night. For centuries, we've believed Earth and its neighbors would enjoy a stable existence until the sun's inevitable expansion billions of years from now. But new research is upending those assumptions, exposing a peril that could arrive far sooner, a peril that has nothing to do with the fate of our aging star. Here's the unsettling truth. Our solar system is not a closed box. It's more like a spaceship adrift in a crowded cosmic sea, surrounded by countless other stars on their own slow, meandering journeys around the galaxy. At any given time, we're not alone. We're surrounded by neighbors, and sometimes those neighbors drift dangerously close. What if I told you that, within the coming billions of years, the odds of a cosmic drive-by are not only real, but maybe far more frequent and far more devastating than anyone previously believed? This isn't science fiction. Recent simulations suggest that even before the sun runs out of fuel, the gravity of passing stars could wreak havoc on the delicate choreography of planets. We're facing the possibility that planets, including Earth, could be ejected from the solar system, flung into the cold darkness of interstellar space, or sent careening into new catastrophic orbits. And perhaps the most alarming fact? This instability could happen sooner, and more often, than we ever thought. To truly understand what's at stake, let's wind the clock back. For centuries, astronomers drew comfort from the clockwork regularity of Newtonian physics. The solar system, it was thought, followed laws as precise as any fine-tuned machine, every planet locked into a predictable path guided by the gravitational pull of our sun. But as science advanced, cracks appeared in this reassuring picture. The late 19th century mathematician Henri Poincaré changed everything by demonstrating that multi-body systems, like our solar system, are inherently chaotic. The more objects you add, the more unpredictable the outcome becomes. Tiny nudges, over time, can grow into wild swings. Fast forward to the last few decades. Powerful computers allowed scientists to run n-body simulations of our solar system for billions of years into the future. Initially, these simulations suggested relative stability, with catastrophic events, like a planet being ejected, appearing unlikely within the sun's lifespan. But there was always a catch. These models assumed our solar system was isolated, sealed off from the gravitational chaos outside. That assumption no longer holds. Our sun and its family of planets are not static. They're travelers, completing a grand orbit around the Milky Way every 225–250 million years. And as we make this journey, the solar system passes through crowded spiral arms and sometimes brushes dangerously close to other stars. These cosmic neighbors aren't just distant pinpricks of light, they have mass, and their gravity can tug at the very fabric of our planetary order. According to a new paper published in the journal Icarus, the threat from passing stars is both imminent and far more serious than previously understood. Analyzing the paths of stars moving through our galactic neighborhood, researchers found that over the next 5 billion years, roughly the time it takes for our sun to become a red giant, the solar system will experience approximately 19 close stellar encounters every million years within just 1 parsec, or about 3.26 light-years. That's closer than Proxima Centauri, our current nearest neighbor. In other words, the chances of our solar system being gravitationally nudged by a passing star are not only real, they might even be expected. These encounters, rare on human timescales, add up quickly in cosmic terms. But what would that actually mean for us? To answer that, scientists constructed elaborate simulations, running countless scenarios of our solar system's future. The results are unsettling. In 2% of all modeled outcomes, at least one planet is lost within 5 billion years. That may not sound like much, but when the stakes are the very existence of Earth, even a fraction of a percent should make you pause. Let's break down some of the most eye-opening risks. Mercury, the innermost planet, is especially vulnerable. Its close, eccentric orbit already puts it at higher risk from any external perturbations. The simulation found that small variations, such as a nudge from Neptune's orbit or the influence of another planet, could send Mercury spiraling out, either crashing into another planet or being ejected into the abyss. But it gets worse. The threat isn't limited to Mercury. Earth, despite its seemingly safe distance, faces a 1 in 500 chance, about 0.2%, of being lost, either through ejection or a cataclysmic collision. Mars, our would-be backup home, fares only slightly better with a 0.3% risk. If you think that sounds remote, consider this emotional reality. In a universe so vast and so ancient, Even low-probability events eventually become inevitable. Our notion of cosmic stability, it seems, is far more fragile than we want to believe. Why is this happening? It turns out the outer solar system is a chaotic place. The orbits of giant planets like Jupiter and Neptune are finely tuned, but also susceptible to the gravitational dance of other massive bodies passing by. These encounters can impart just enough of a kick to disrupt planetary orbits, starting a slow-motion domino effect. Today's stable solar system could, over cosmic timescales, begin to unravel, with planets straying out of their lanes or even being tossed away entirely. Dr. Hal Levison, a leading authority from the Southwest Research Institute, sums it up. Stellar encounters can significantly alter the orbits of outer solar system objects, leading to instability and the potential ejection of planets or the disruption of the Kuiper belt. And it's not just the fate of planets at stake. The Kuiper belt, the icy, far-off region beyond Neptune, is itself a fragile construct. Objects here, like Pluto and the enigmatic Quasar, are relics of our solar system's formation. Recent discoveries challenge the notion that these bodies are lifeless leftovers. In 2023, observations revealed that Quasar is geologically active, with internal heating mechanisms scientists can't yet explain. According to Dr. David Jewett from UCLA, Kuiper belt objects are time capsules, preserving information about the solar system's formation and the composition of the protoplanetary disk. This region isn't just an archive, it's a canary in the coal mine. When a passing star disturbs the far edge of our solar system, the Kuiper belt will be among the first places to show signs of disruption, objects thrown into new orbits, collisions increasing, or even bodies being ejected into interstellar space. Add to this our growing list of cosmic wildcards. In just the last decade, we've watched as interstellar objects like Oumuamua whipped through our solar system, reminders that planetary systems lose planets and planetesimals all the time. Simulations now suggest that our own solar system may once have contained a fifth giant planet, ejected long ago during a period of orbital chaos. With every new discovery, the story gets messier and more alarming. The Atacama Large Millimeter Submillimeter Array is mapping the surfaces of Kuiper belt objects with astonishing detail, revealing a surprising diversity in composition and roughness, clues that hint at a violent, collision-rich history. Binary systems are more common out past Neptune than anyone expected, signaling that gentle accretion and catastrophic breakup go hand in hand here, further supporting the idea that the outer solar system is anything but settled. But perhaps the most tantalizing and frightening prospect lies with the so-called Planet 9. Numerous extreme trans-Neptunian objects move in oddly aligned orbits, leading experts like Dr. Scott Shepard and Dr. Catherine Volk to speculate that a massive, as-yet undiscovered world, maybe 10 times the mass of Earth, lurks far beyond Neptune. If it exists, Planet 9 could be a hidden architect of chaos in the outer solar system, strengthening the effects of stellar encounters and making disruptions even more likely during a close pass. Dr. Renu Malhotra emphasizes, resonances with Neptune play a crucial role in shaping the distribution of objects in the Kuiper belt, influencing their long-term stability and the potential for collisions. It's a dynamic, ever-shifting battlefield where stability is often the exception, not the rule. It's not just theoretical models and distant observations. The New Horizons spacecraft, having revolutionized our view of Pluto, continues its journey into the Kuiper belt, probing the boundaries between the solar system and interstellar space. Each measurement of solar wind, each snapshot of a stray Kuiper belt object adds a vital clue to the puzzle of whether our planetary system is built to last, or destined for upheaval sooner than we dreamed. So, where does that leave us? As humanity eyes Mars and dreams of settling other planets, we must confront the unsettling possibility that even those new frontiers may not guarantee our species' long-term survival. The threat from passing stars is unpredictable, lurking beyond the horizon. Will we find the means to protect our world, perhaps by moving planets to safer orbits, as some futurists propose? Or are we simply at the mercy of forces far beyond our control? As the solar system speeds on its 200-million-year journey around the galaxy, it will inevitably pass through denser regions, bringing us closer and closer to cosmic danger. Each close encounter with a rogue star is a cosmic roll of the dice, one that, eventually, may land against us. Are we prepared to intervene, or will we resign ourselves to a fate written in the stars? Here's the burning question. With the clock ticking down to our sun's demise, could a rogue star spell the end of Earth, and possibly all life, long before our star ever has the chance? The second half of our story will trace the real possibilities, the potential technological solutions, and the ethical dilemmas that humanity may soon face if we want to beat the universe at its own game. So now that we've seen how our solar system isn't quite the cosmic safe haven we once imagined, the ultimate question remains: what comes next for us, and for humanity's place in the universe, when faced with these unpredictable stellar threats? Imagine, just for a moment, the distant future unfolding not as a slow, predictable fade-out with the sun's eventual death, but as a series of cosmic dice rolls. Every few million years, as our solar system drifts through the galaxy, it passes dangerously close to other stars. Most of the time, nothing happens. But sometimes, a passing star tugs ever so slightly on Neptune or nudges a distant dwarf planet. That gentle nudge, amplified by gravitational chaos, sets off a chain reaction. A billion years later, Mercury is gone, or Mars is on a collision course. Or, in the unluckiest scenarios, Earth itself is thrown out into frigid interstellar space, a rogue world, dark and alone. This isn't mere science fiction. Recent simulations show that over the next 5 billion years, the chance of losing a planet is small, but very real. As Dr. Hal Levison warns, stellar encounters can significantly alter the orbits of outer solar system objects, leading to instability and the potential ejection of planets or the disruption of the Kuiper Belt. And as our astronomical tools improve, from Gaia's stellar census to the mind-bending data of James Webb, we're starting to see how plausible these threats truly are. But let's dive deeper. What are the future scenarios and opportunities that could play out in the cosmic game of chance? One path is discovery. Our telescopes are probing the outer reaches of the solar system, searching for the elusive Planet 9, a hidden world that, if real, could dramatically reshape our understanding of solar system stability. Dr. Catherine Volk notes, "The orbital alignment of distant Kuiper Belt objects provides compelling evidence for the existence of Planet 9, which could have a significant impact on the stability of the outer solar system. If Planet 9 is found, we might have to rewrite the textbooks on how our solar system will evolve, and whether its planets, including Earth, can survive in the long run." Then there's the technological path. Picture this. In the far future, advanced civilizations, perhaps us, perhaps our descendants, could detect an incoming stellar encounter millions of years in advance. Science fiction? Maybe, but already scientists are discussing how propulsion systems might one day allow us to move planets, nudging them into safer orbits. It sounds wild, but so did flying to the moon, once upon a time. Can we step into the shoes of cosmic engineers, reshaping the solar system to survive the turbulence of the Milky Way? Yet another scenario is adaptation, not just of technology, but of humanity itself. If Earth were threatened, or worse, ejected into the void, can we build habitats elsewhere? Could Mars or the moons of Jupiter become new refuges, once merely backup plans, now vital for our survival? As the New Horizons spacecraft continues sending data from the very edge of the solar system, NASA and other agencies are already thinking about outer solar system exploration and even colonization. Of course, these possibilities are matched by real risks. As our understanding deepens, we realize that the solar system's history is a story of chaos, a tale written in gravitational equations and punctuated by catastrophe. A well-placed nudge from a passing star could not only scramble planetary orbits, but trigger a cascade of comet impacts, planetary migrations, and even the ejection of a planet, just as simulations suggest may have happened once to a lost ice giant from our solar system's youth. Meanwhile, every discovery about the outer solar system deepens the intrigue. Quasars' unexpected geological activity has stunned astronomers, hinting at mysterious internal heating processes in the distant cold. Binary trans-Neptunian objects, pairs of icy bodies orbiting each other, defy old formation models, challenging everything we thought we knew about the building blocks of planets. Even the interstellar visitor Oumuamua, perhaps the fragment of a destroyed exoplanet, reminds us how easily objects wander between stars, carrying secrets, sometimes dangers, with them. But what does all this cosmic drama mean for us here and now? How can understanding the universe's instability possibly benefit you, besides giving you a great story to tell at parties? First, it's a lesson in humility. We like to think of our world as safe and permanent, but the universe reminds us, nothing lasts forever. The solar system is less a clockwork and more a game of cosmic billiards. Recognizing this, we can appreciate the beauty and the fragility of life on Earth. Every sunrise, every breath, is a lucky roll in an ancient, ongoing game played across billions of years. Second, it's a call to scientific curiosity. Look at the wave of discoveries happening right now: the search for Planet 9, the exploration by New Horizons, the mapping of the Kuiper Belt and Oort cloud with ALMA and JWST. Every new piece of data helps us understand not only our own past, but the fate of exoplanetary systems throughout the galaxy. The lesson? The more we know, the better equipped we are to spot trouble on the horizon, or a chance to innovate our way out. For future generations, this knowledge could be the difference between extinction and survival. By understanding these cosmic threats, we can begin to plan, not just our immediate space missions, but the long-term destiny of civilization. Will we build planetary defenses, like redirecting comets or adjusting Earth's orbit? Will we develop technologies to survive on other worlds, long before the sun or a rogue star forces us to flee? Today's research is the seed of tomorrow's lifeboats. There are practical payoffs here and now, too. The technology we develop for deep space exploration, advanced propulsion, life support systems, powerful telescopes, feeds back into our daily lives, from new materials to improved communications. And the awe generated by cosmic discovery inspires children and adults alike to pursue science, engineering, and dreams of the future. But perhaps the most important lesson is perspective. When we look up at the night sky, seeing the infinite number of stars, we realize our solar system is special, but not unique. Exoplanetary studies show that planet ejection and rearrangement is common. Our continued existence, stable and safe for now, is a rare cosmic gift. That knowledge can foster a sense of stewardship, not just for our planet, but for any world humanity might one day inhabit. So, can we ultimately defend ourselves against the unpredictable forces of the universe? The honest answer is, to an extent. We are not powerless. With each technological advance, from telescopes that can spot distant stars on a collision course to theoretical ideas about moving planets, we chip away at helplessness. But the universe is vast and ancient, its physics inexorable. Some events are simply beyond even the most advanced civilization's control. A massive star passing too close, 1 billion years from now, may still sweep away planets with a flicker of gravitational force. Our best defense is knowledge, to foresee as much as possible, prepare where we can, and adapt as needed. In the end, the story of the solar system's future is unwritten. It's shaped by cosmic chance, but also by our curiosity, ingenuity, and will to survive. Whether humanity becomes a fleeting footnote or a multiplanetary species is, in part, up to us, and what we do with the knowledge we're gaining right now. And one last secret, a thought to carry with you. Some astronomers suspect that lurking at the very edge of the solar system are objects, not just planets, but perhaps even primordial black holes or fragments of failed stars, waiting to be discovered. Each new finding, each unexplained anomaly in the outer solar system, is a reminder that we haven't yet solved all the mysteries. The universe still has secrets, and some of them may change our understanding of fate itself. So next time you look up at the night sky, remember, the dance of planets and stars is grand, beautiful, and unpredictable. Our best hope is to keep asking questions, keep discovering, and never stop exploring. Because in the vastness of space, every answer brings us a little closer to understanding our place in the cosmos. If this journey into cosmic uncertainty intrigued you, give the video a like, subscribe for more mind-bending astronomy, and let us know in the comments.